In this tutorial, I am going to show you how you can extract sequences from a FASTA file using Python. And so for this tutorial, you need to make sure you have Python installed and you also have the Python library BioPython installed. So this one I am highlighting here, just make sure you have it installed. If you don't have Python on your PC, you can use the Google Colab platform. So this is the page. I'll leave the link to this page in the description box. So with Google Colab, it allows you to run Python code using your browser. So just visit the page and then just come to this side here, new notebook, and then just click it. So once you click it, you'll be given a new notebook and then you can start using it for your work. Alternatively, once you are here, you can click outside and then just come to File and then come to New Notebook and then just also click it, and then you'll be given access to a new notebook that you can use to run your Python codes. So once you are here, you can install the BioPython and then you can start with the activity. I have separate tutorials on Google Colab, so you can just watch those videos to get started and set up your PC. So let's get back to work. So with this tutorial, because we are going to extract sequences, we need an example data, and I have one on one of my GitHub repos here. So it's called Bioinfo data. So just go to that repo and then you get some data here. So I'll leave the link to this repo in the description box as well. So just use that. So here, just look for gens.fasta, this file here, gens.fasta, and then just click it. This is what we are going to use. So click it and then you be sent to another page here. You can just explore, but we want to download for now. So just come to raw, this side here, click on raw. And then once you are here, just right click and then just go to save page as, and then I'll just save it. Yeah, I'll save it on my desktop. Yeah, somewhere here. Yeah, I'll just save it here on my PC here. So just save it in an appropriate path. So I'll just save it with the default name. Okay, so it's done. Let me just go there. I'll open that file. So FASTA files are just text files, but they have a particular format. I'll just open with a text file just to show you. Let me show you how that is. Okay, so this is how it is. This is a FASTA file. So with FASTA files, you have, let me just see whether I can zoom in a bit here for you. Let's check. Okay, I think I'll use a different text editor. Yeah, perfect. This one should be okay. Yeah, so FASTA files contain sequences. So if you have more than one sequence, it becomes a multi-FASTA file. So here we have a multi-FASTA file. It has several sequences here. Each sequence begins with this symbol here, the greater than symbol. And we have the sequence name. We also have description and then some information here. So, and then we have the sequences here. So we have lots of them here. So we are going to look at how we can extract sequences using some example sequences here. We have lots of them here. So we look at some of them and then just use Python to extract the ones we want from this data. So that's what we are going to do. Okay, now let's get back to our Jupyter notebook. Let's get back. Perfect. So I am here. But before that, you also need to take note of the path where you are working. It's important you get that. So I will need that information as well. Now let's get back here. So the first thing I'll do is to import my BioPython models, the ones I'll use. Here I'll use the SeqIO. So I'll say from bio import SeqIO. That's what I'm going to use. Let me just give a comment here. Okay, yeah, so I have it imported. This is what I'll use. So once I have it, I will now read my FASTA file. So let me just put a comment here. I'll just read it here. Okay, now let's proceed. So First of all, before I read, I'll make sure I give the path to the file. So let me just say file name. My path is /home. There's my full path. Let me just check. Yeah, so there's the full path, so it's fine. Make sure you also do same. Okay, so this is my file name. Then I'll use the BioPython SeqIO model to read. So I'll say sequences. I'll use a list comprehension here to speed it up. So I'll say I for I in SeqIO.parse. File name FASTA. This is how I'm going to read it. Let me just enlarge the interface here for you to see it clear. So I have a number of sequences here, and all of them will be read, and then they will be in a list file. Okay, so now I have it done. So let me just check the length. So I'll say length sequences. I just want to look at how many sequences I have. I have 219 of them here. These are the sequences I have. And so we are good to go. Okay, so let me just look at, we can just explore. Let's look at some of them here. Let me just look at the first sequences. So let me just, the first sequence, let me just say sequence A is equals to sequences. Because it's a list, I want the first element. This is how it is. I will just get it, and I will say sequence A dot name. I just want to get the name. It's called DNA A. You will notice that we had it here. When we look at the FASTA file, we have DNA A. This is the name, the first sequence in the data. So it's the same thing we have here. Okay, so we have it there. We can explore, we can even check the length, we can check sequences, but these are things I've covered in separate tutorials. So I will leave that playlist at the end of this video. Let's focus. Our tutorial today focuses on extracting some sequences. So let's say we want to extract this sequence, this particular sequence here. Okay, this one we've done it. Let's just look at another one just so we know what we are doing. Let's look at another example here. So let's say we have this sequence, this one here, RECF. Let's say we want to extract this to a separate file. Here we use loops, and we also use some if statements to get it done. So I will show you how it's done. So let's say we want RECF, the sequence RECF. We just want to extract it to a separate file. So what I'll do is to first do a loop. So I'll say, let me just put it here. Because it's one, I'll just say, let me just say gene of interests. I'll just put it this way. I'll just make it simple. Okay, so I'll have this list created, and then I'll say for sequence in sequences, if sequence.name equals RECF, then I'll put it here. Gene of interest dot append sequence is just one, so that is why I have just this name here for it. So gene of interest dot append sequence. You can also assign this to the same name, but it depends on what you want to do. But I just want to make it simple for all of you. So that's what we are going to do now. So I'll just do it this way, and then I'll run it. And so when I do learn gene of interest, I'll find that it's 1. Okay, you can do it this way, or you can do it this way. You can just use the same command here, but this time instead of a list, because it's just one sequence, you can just say gene of interest equals sequence, and then I'll just exit it. So when I say gene of interest dot name, I'll get it here. So either way works fine for you. So it doesn't matter. Once we are dealing with just a single sequence, any of these approaches should work fine for you. So now we can save the sequence. So I'll say SeqIO.write, and then I'll say gene of interest, and then I'll give it a name. So let's say /home/ I'm using the same path here. This becomes my name, and then I'll indicate the output format, which is FASTA. Let me make it smaller bits. So I have it here like this. So once I have it here, I can run this to save this file. Okay, so notice there is 1 here. This means that only one sequence was saved. So if you go to the folder, you will have it here. So open it, and then you see this sequence here. So this is how we extract a sequence from a FASTA file. Let me just get back here. So this is how we save a sequence, or we extract a sequence from a multi-FASTA file. So that's it. Now let's look at another problem. Sometimes you have more than one sequence and you want to save all of them. Let's say you have about 3 sequences. You want to extract all of them and put them in a single FASTA file. We can also do it that way. So let's look at this situation. Let's say we want, let's go back. Let's say we want DNA and we want RECF, these two. We want all of them extracted to a single FASTA file. Let's get back. Some of these things, it depends on what you want to do, but I'm just trying to give possible scenarios here that should serve as a guide for you. So you have your genes of interest or sequences. Let's just say sequences. Sequences of interest. So you label them. We have DNA and we have RECF. These are the ones you want. So you make sure you put them in a list. And then we iterate and then we get that information here. And so here, what happens is we need to define a function. It's much simpler to define a function that you can use to kind of automate the process, because if you're dealing with several or hundreds of sequences that you want to extract, then the functions will help you to do that without having to rewrite the codes. So let's create a function. So you see def extract sequence. So we put the sequence name here. And so here we can use the same command here. Like this, I'll modify it a bit to suit what we want. And so what I'll do is to still iterate through this sequences, this list we created initially that has the sequences. So that is what I'm doing here. And then I'll just ask the question again, but this time I'll say sequence name, because we are going to put in a sequence name here. And then I'll just put, let me just put a name here. Let's say gene of interest. I'll just put it this way. So I'll just say gene of interest equals sequence. There are different ways you can do it. So you can have much optimized codes, but these are simple codes you can always modify. And so I have it this way, and then after that I'll say return gene of interest. You can have it this way. Another way you can also do is to just make it simple. You can just clear it. Let me just put it this way. You can clear it, and then you can just say return sequence. This is much simpler. Okay, I'm just showing you different ways you can use to get the sequences. This is much simpler. So here it iterates through the sequences, and then after iteration it just returns the one it wants. Here I am assuming that each sequence name appears once. That is the assumption for this tutorial. So just take note of that. So once you have this, you can run this code anytime you want. So here, what I'll do is that I'll now use another loop to iterate through each of these and then put them there. So I can say, let me just put them here. Let me say genes of interest again. Yeah, genes of interest. I'll just put it this way, and I'll say for gene in sequences of interest. Then I'll say hit equals extract sequence, and then I'll use the name gene. Here I'm assuming that whatever name we have here is present in the original sequence. So that is what we are doing now. So once I do it this way, I'll then append. So I'll say genes of interest.append hits. So I'll have it like this, and then I'll run this code. So here I'm using this function for this and this as well. The only thing I change is the name, which comes here. Okay, so now if I do learn genes of interest, we are going to have 2. And so these 2 genes here, we can now save them to an output file. So let's just say, let's use the SeqIO. So you can say SeqIO.write genes of interest, and then we give the path. So let's say the same path here that I used. And then I give the format. Let me just say hit. Let me just put it this way. Yeah, so once I have it this way, I can run it and save this file. So you have 2. So if you go to your folder, you should see gene hits here, which has the 2 sequences here. So we have them nicely done for us. So we have DNA A, and we have what RECF also here, nicely done for us. So these are things you can do to extract sequences from a FASTA file. What we did was to extract sequences from a single multi-FASTA file, but there may be situations where you have several files, okay, several FASTA files, and you want to extract sequences from them. But these are things I'll cover in later tutorials. So let's say you want to save each of these 2 sequences to a different output file. This is how we do it. We will still use the same command here. We will just do a modification here just to save it. So here we will still iterate, and then once we get the hits, we will define where we want to save it. So I will say output name, and then I will say /home here, and then I will just say there's a strange formatting technique, and then I will just give the name here like this. So this will be the output name. So this allows us to have a customized name, which is the names of the gens here that we use. So once we do it this way, we just say SeqIO.write and we give the output name, not the output name, the sequence first hits output name, and then we say what? FASTA format. And so once we do it this way, we run it and then we have it done for us. So here, if you go to the folder, you will see the names here. Notice we have DNA, which has the DNA file. And then if you check, you also have the RECF, which also has the sequences for RECF. I don't know why I'm saying RECF sequence here, also in a separate file. So depending on how you want it, you can decide to get the sequences of interest, save them in different files, or combine all of them into a single file like this one here. So it depends on you and what you want to do. And so that's how I will do it. So with Python, there's that flexibility, and so you just need to experiment and look at what works best for you and then just use that. So that'll be all for this tutorial, and I'll make this notebook available on my GitHub repo. I'll give the link in the description box. So in case you want to download this notebook, you are free to do that as well. So that'll be all for this tutorial. Thanks for watching, and I'll see you in the next session. Goodbye.